Hello everybody. So I've got a little issue to solve here, and the problem that we're trying to deal with is how to make sure the robot is parallel to the wall of the VexIQ field in order to basically reset and start through a next portion. So I basically just drew out a little piece here. So the premise that we're trying to go with is essentially two sensors. One's on the front left and one's on the rear left. There's a couple different situations we could be looking at. So either one is parallel, like you see up in the top, or the second one down here is the front left is less than rear left, which means I'm turned slightly to the left. Or the last one here is the rear left is less than front left, which means I'm turned to the right. So over here on the program itself, I've added a number of different comments we'll go through. So all the stuff that you do ahead of time to collect things and put them in the corner, essentially that all happens prior to this portion. And then next we want to make sure to stop everything, so I have the stop all motors. Then I set the variables to assign the measurements from each sensor to the particular variable. So front left we see is assigned the data, or essentially the value, from the distance measurement of the front left sensor. Same thing with rear left. Now the robot has measured the distance from the front left to the wall and rear left to the wall. We can determine which way the robot is turned in relation to the wall. Then we start a check and loop. This loop runs while the front left is not equal to rear left, meaning it's slightly turned. So look at this while. While front left is not equal to rear left, we go through this portion. Okay, so essentially what it does first is if front left is less than rear left, it turns to the right, which means if the robot's slightly turned like this, then we're going to be turning slightly to the right. We don't want to turn too much because we want to turn a little bit and take a measurement and continuously do that. Now, if the opposite is true, so meaning the front, this if here, so front left less than rear left, meaning if that's not true, then we're going to go down to the else. So if rear left is less than front left, that means we're going to be on that third part over here. Then we're going to do this other portion, so that's the turn to the left slightly. So that's one rotation 25. So we're doing this slow and hopefully small increments. So we're going to see above is that while front left not equal to rear left, the if-else statement runs. The if-else determines what to do based on the values of the variables. If front left is less than rear left, then it turns slightly to the right. Else turns slightly to the left, like we just talked about. So once it makes a slight turn, these following lines need to run to essentially just check the sensors again and assign the value into those variables. So basically turning slightly, measuring, and then again if they are not equal. So essentially it just continues to run until it's equal. So you can see there again, the front left not equal to rear left, then we continuously turn. And down here at the bottom, once it makes that little turn, we want to assign the data or value from the distance sensor back to the variable, and then from the other distance sensor back to its variable. And then hopefully what happens as this thing continues to run is eventually this loop is going to exit because front left will be equal to rear left. And once they are equal, then we know we're back over here in the parallel line. And once we are parallel, then we can continue on and do the next piece now that we've checked to make sure we're parallel with the wall. And that's basically all there is to it. So we're just taking the distance measurements from the sensors, assigning them to values or the variables, and then doing this quick little while loop to get the thing to ride itself, and then continue on. If anybody has any questions, feel free to let me know.